हेलो एवरीवन, वेलकम टू द सेशन. सो आई होप आपने पहला सेशन देखा होगा ऑफ आवर वंडरफुल सीरीज एनसीईआरटी लाइन बाय लाइन, in which we did 25 important questions of class 11th syllabus. Okay, उसमें जो थे वो चैप्टर नंबर 1 से लेके अप टू थर्मोडायनेमिक्स क्वेश्चंस मैंने इंक्लूड किए थे. Now in this session I'll discuss second part of this particular important series. This is physics का session number 2 everyone, जहाँ पे मैंने सिर्फ और सिर्फ 3 बहुत ही important chapters include किए हैं. First is your electric field and charges, second is electric potential and capacitance, and third is current electric current. ठीक है, तो इन तीनों चैप्टर से बेटा हमेशा एटलीस्ट 5 to 6 क्वेश्चंस आते हैं एंड द चैप्टर इज़ वेरी इजी. I'll show you how to frame questions using lines of NCERTs over here. देखो क्वेश्चन को ऐसे फ्रेम किया जाएगा कि आपको पता नहीं चलेगा कि डायरेक्टली NCERT से आया है. So that is why we are here with this wonderful series NCERT line by line. So guys, आई होप आप सब लोग अच्छे होंगे और बहुत ही जोश के साथ हम ये सीरीज स्टार्ट करेंगे, सेशन स्टार्ट करेंगे. बट उसके लिए जो जोश है मुझे कमेंट बॉक्स में भी यहाँ पे दिखना चाहिए, एज वेल एज यूल हैव टू कीप ऑन आंसरिंग द क्वेश्चंस. ठीक है, हम लोग मिलके क्वेश्चंस करेंगे, बट आई वांट योर आंसर्स इन द चैट बॉक्स ओवर हियर. So my name is Vibhati and I'll be taking your physics classes in NCERT line by line. Alright, so guys, let's start with question number 1. Figure shows the electric lines of force emerging from a charged body if the electric field at point A and point B are EA and EB respectively, and if the distance between A and B is R, then which of the following options is correct? ठीक है, hello, hi Teja, hello Jayanti, hello everyone, good to see you all. Right, so we have a figure of electric field lines and this is point A, this is point B. Electric field at point A is EA, here it is EB. Then what is the correct solution for this one? A, B, C, D. You have 4 options over here. Try this one everyone, try this one. This is based on the properties of electric field lines. Fine. So if you know those properties, you can do it clearly and within 10 seconds. क्या होगा बच्चों? Come on guys. I want your answers in the chat box, everyone. Anyone? Teja, Jayanti. Option A, option D, well done, well done. We have 2 options for a single question, well done. Alright, so see over here where the point A is, the electric field lines are close to one another. देखो point A जहाँ पे है electric field lines are close to one another, whereas at the location of point B the electric field lines are slightly far apart from each other. The separation over here is large as compared to this one, and if electric field lines are closer, that means electric field in that region is strong, and if electric field lines are far apart from each other, that means in that region electric field is less strong. Right, so over here you can see that it is closer in this region, so EA is greater than EB. So correct answer is option A. Correct answer is option A. Well done guys, well done, good job everyone. Now those who are making mistake, guys, make a note of it कि mistake क्यों हुआ, what is the exact reason of the mistake, and I'm sure you will not repeat this mistake again. Right, so with this parallelly make a column and write your mistake and write that one below your mistake one more line that I will not repeat this mistake in my life. Okay, so this is the concept for question number 1. Now next is this one, 2 point charges plus 2 coulomb and plus 6 coulomb repel each other with a force of 12 Newton. Now if a charge of -4 coulomb is given to each of these charges, then what is the new force between these two charges? ठीक है, try this one everyone, try this one. We have +2 +6, the force of repulsion is 12 Newton. Now if I give -4 coulomb to each of these charges, then what will be the new force of repulsion? Directly based on Coulomb's law, right? K Q1 Q2 upon R square. Alright, try this one. This is based on Coulomb's law मेरे बच्चों. Try this one. Come on guys. What is the answer for this one? Everyone, this is question number 2 of our wonderful, beautiful 25 questions, important questions for NEET. Those who are late in the session, I will tell you this thing one more time, that I have included questions of 3 chapters: electric field and charges, electric potential and capacitance, and current electricity for this one. ठीक है, चलो चलो everyone, क्या होगा? Option B from Jayanthi, well done, well done. Okay, it should be 4 Newton attractive. ठीक है, let's see. If you look at this thing carefully, there are only 2 possible options बच्चे, right? देखो, initially the force is repulsive. Once you give -4 coulomb to each charge, the net charge for this one will be -4 + 2 -2 coulomb, and this will be -4 + 6 + 2 coulomb. ठीक है, so these are unlike charges. Now the force, new force between these two will be attractive in nature, right? Because unlike charges. Well done Teja, well done. So over here only B and C are possible, A and D are not possible, right? Okay, so with every question try to learn a new technique, how to eliminate options. Sometimes with the help of elimination of the options, you can mark correct answer even without solving the question, right? All right. So over here, see, let's say the separation between these two charges is R. So old force is K Q1 Q2 upon R square is equal to 12 Newton. Right, so K into 12 is equal to 12 R square, right? So K is equals to R square. This is my equation 1. Now new force will be what? Here it will be K Q1 Q2 upon R square. So over here this will be K is R square. So R square into 4 divided by R square. So it will be 4 Newton. Magnitude is 4 Newton, but it will be attractive in nature. So correct answer is option B. Well done guys. Good job everyone. Option B is correct. Now next is this one. 2 parallel metal plates having charge plus Q and minus Q face each other at a certain distance between them. Okay, if the plates are now, this is like arrangement is kept in air or vacuum. Now these plates are dipped in a liquid. Which liquid? Kerosene oil. है ना? We are keeping these plates in the kerosene oil over here. Then find the electric field between the plates will. What will be the change in electric field between the plates? Will it become 0, increase, decrease, or remain same? Try this one. Try this one. This is again the concept of, change in medium. When you change the medium, the force and the electric field changes. Will it increase? Will it decrease? That you have to decide. Okay. Coulomb's law is 1 upon 4 pi epsilon naught Q1 Q2 upon R square, that is force. Epsilon naught is the permittivity of free space. Now when you change the medium in which the charges are kept, the epsilon value will change, and because of that the force between these two will change. We have option C from Tesha. Option C, well done, good job beta, right? So if force is changing, electric field over here will also change. What is the electric field due to a plate of charge? It is sigma upon epsilon naught, right? It is sigma upon epsilon naught. So between these two, if let's say A is the area of cross section of these two plates over here, then over here it's sigma is q upon A, okay? And for this one it will be minus sigma, which is minus q upon A. So between the plates, if I am considering these two identical plates, then between the plates over here, because of this positive charge, electric field will be away from it, right? And that is sigma upon 2 epsilon naught. Similarly beta, because of negative charge, electric field will be towards it, and that will be again sigma upon 2 epsilon naught. So what is net electric field between these two identical plates? It is sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught, that is 2 sigma upon 2 epsilon naught. So it is sigma upon epsilon naught, right? But this will be when the medium between the plates is air or vacuum, right? When you change the medium to kerosene, let's say its relative permittivity is K, then over here electric field will become sigma upon K times epsilon naught, because permittivity is relative permittivity, permittivity of a medium is relative permittivity into epsilon naught. So let's say permittivity of the kerosene is epsilon, ठीक है बेटा? So over here it is 1 upon K times sigma upon epsilon naught, where sigma upon epsilon naught is old electric field, so it is E times 1 upon K. So you can see that in denominator we are getting K, and K value is greater than 1, right? So if denominator is increasing, it is more than 1, then overall value of electric field will decrease, right? So correct answer is option C beta. I hope it is clear. Alright, option C is correct. Well done Teja. Now next is this question for you, the electric flux through the surface. There are 4 surfaces beta of different size and shape. We need to find or compare the electric flux through 1, 2, 3 and 4 surfaces over here, right? This is something random, this is spherical, this is like elliptical, this is again something random amoeba like structure, right? So try this one everyone. This is based on Gauss law, right? Not Gauss law, basically this is just, you know, the concept of this is Gauss law. ठीक है? Electric flux through this surface. Alright, what is the answer everyone? This is question number 4. क्या होगा guys? What is the answer? Meanwhile, you can also share this session with your friends, okay, so that they can get maximum benefit and you all can go to a decent college together. अकेले पढ़ने में क्या ही मज़ा है ना? कॉलेज में तो दोस्तों की ज़रूरत पड़ती है. So invite your friends also. Share this session with your friends. Okay, what is the answer? Guys, try this one. Electric flux through a closed surface is Q enclosed divided by epsilon naught. Q enclosed divided by epsilon naught. We have option C. Okay, you can see that the enclosed charge, it doesn't matter where it is kept, है ना? We don't need the location of the charge, we don't need the shape of the surface over here. We just need how much charge is there inside the surface. Well done Shubham, well done Teja. Option C, okay. Alright. So total charge inside each surface is same, which is equal to plus Q divided by epsilon naught. So flux through each surface will be Q upon epsilon naught only, because the charge which is inside the surface is same for all, right? So flux through each surface will be same. Option D is correct guys. So mark your mistake over here and write it down in the column. ठीक है, बाजू में एक column बना लो, उसमें लिख लो कि this is the mistake that I did in this question and I'll not repeat this mistake one more time, right? Well done guys, well done. Good job everyone. Now next is this one. The figure shows the path of a positively charged particle 1 through a rectangular region of uniform electric field as shown in the figure. What is the direction of electric field and the direction of particles 2, 3 and 4? So देखो in this region, in this rectangular region we have some uniform electric field. ठीक है बेटा? अभी I don't know what is the direction of electric field, but once I throw the particle 1 inside this electric field region, it deviates like this, है ना? It is moving towards top. Then आपको बताना है कि what is the direction of electric field in this one, and if you throw 2, 3 and 4 particle also in this region, where they will move, top or down? Fine. Chalo, try this one everyone. Come on bachcho. Very nice question based on the concept of force on a charged particle in uniform electric field. ठीक है? If charged particle is positive, it will experience force in the direction of electric field. If the charged particle is negative, it will experience the force, electric force in the opposite direction of electric field. ठीक है? It is based on that. Fine? चलो, come on guys. क्या होगा? What do you think guys? Come on everyone. Come on guys. If it is positive charge and it is deflecting towards top, that means the electric field should be towards top, है ना? Because it will deviate in the direction of electric field. So over here electric field is top. Now if you throw this negative charge in this region, so it will deflect towards down, because it will, if electric field is upward, it will move in the downward direction. Well done beta. Option A from Jayanti. Well done. So second will move towards down, then third particle is it is positive, so it will move towards top, and fourth is again negative, so it will be down. So top down, top down. Option A is correct. I hope it is clear everyone. Option A is correct बच्चों, right? चलो, well done guys, well done. Good job everyone. Okay, देखो कुछ भी solve नहीं करना था. You don't have to solve anything. Look at the length of the question, but the solution is very simple. It is based on a very basic statement बच्चे, right? Alright, now try this one. A sample of HCl gas is placed in an electric field of 3 into 10 power 4 Newton per coulomb. The dipole moment of each HCl molecule is this much. Then the maximum torque that can act on a molecule is, what is the torque? Well done Shubham, well done. Tau is P cross E. PE sin theta beta. If it is maximum, then sin theta should be 1, right? Well done everyone. Chalo, try करो इसको. क्या होगा? What is the answer everyone? है ना easy everyone, right? So if you know your basic concepts clearly, then every question will be easy for you. PE sin theta, we want it to be maximum, so for that sin theta should be maximum, and sin theta is maximum when it is 1, when the angle between P vector and E vector is 90 degree. So maximum value of torque will be just PE. So it is 3 into 10 power 4 into 6 into 10 power minus 30 beta. So it is 18 into 10 power minus 26 Newton into meter, right? Yes, option C is correct. Well done guys, well done. Good job everyone. Alright, next is this question. Charge Q is uniformly distributed over a half ring of radius r. We have a half ring of radius r, ठीक है? And charge Q is uniformly distributed over it like this. Alright? Then what is the electric field at the center of this ring? Okay. What is the electric field at the center of this ring? Well done. So guys, यहाँ पे I have included this question like essay so that you will learn about the process of integration over here. This question is lengthy, but you will love this question. I'll explain it to you, right? So it is based on the process of integration, bachche, right? Although you will not find this lengthy questions in NEET, but you can directly remember the formula. Okay, you can directly remember the formula, right? So what I'll do is, I'll find first of all, if R is the radius of this half ring, then what is the length of this half ring, beta? It is pi r. So pi r length has q charge, beta, right? So one length, unit length will be having q upon pi r charge, coulomb charge, right? So this is nothing but its linear charge density. Charge per unit length is known as linear charge density lambda. So this will be the charge on unit length of this wire. Okay? Now this half ring. Now I'm taking one small element at an angle theta from the vertical, and the width is this much. So if this small angle is d theta, then this arc is r d theta. है ना? Arc is nothing but radius into angle. So over here the length of this very small element whose angular width is d theta is r d theta, because angle is arc upon radius. So arc will be angle into radius. What is the angular width? D theta. So length of the small element is r d theta. ठीक है बेटा? Now come to this point. If unit length has this much charge, then this much length will be having what charge? है ना? If unit length has q upon pi r charge, then this, let's say length is dl, very small length dl. dl length will be having charge on unit length into length of the wire, which is r d theta. है ना? r cancel. So it is q upon pi into d theta. So this is the very small charge on this element over here, which is dq. Fine. This is the very small charge on this element, which is dq. Now dekho. Now over here I know ki what is the electric field due to a point charge. So this is a very small charge. Electric field due to this point charge will be what? K dq upon r square. ठीक है? K dq upon r square, right? Electric field due to this point charge will be k dq, kq upon r square. So q is dq, so it is k dq upon r square. ठीक है? Now over here what I'll do is I'll integrate it. Now let's find the direction of electric field due to this charge. It will be away from it. This electric field is very small, dE, right? Now if this angle is theta, then this is also theta. So this component of electric field is dE cos theta, and this component of electric field is beta dE sin theta. ठीक है? Now if you take one exactly mirror element over here, है ना, exactly having d theta, having charge dq, then its electric field will be in this direction, away from it. If this is theta, then this is also theta, right? So if you take the component of this element, this electric field, which is of this element over here, then this will be, this component will be dE cos theta, and this component is dE sin theta. So you can see that dE sin theta and dE sin theta are cancelling one another. है ना बेटा? So net electric field is 2 dE cos theta in the downward direction, right? Net electric field is 2 dE cos theta in the downward direction over here. So it is 2 dE cos theta in the downward direction. What is dE? K dq upon r square. So it is 2k dq upon r square into cos theta in the downward direction, right? Now this theta can vary from, we are taking theta with respect to this. So it can go from 0 degree to 90 degree like this. So the limits of the angle will be 0 to 90 degree, right? So once I integrate this thing, I'll get my total electric field from 0 to pi by 2. Right, so this is 2k upon r square, dq is q upon pi, and d theta हो जाएगा, so it will be cos theta d theta from 0 to pi by 2, right? Fine. So over here it is 2kq pi r square. Cos theta integration is sin theta. We'll have to put upper limit and lower limit like this. So upper limit is pi by 2, sin pi by 2 will be 1 and sin 0 will be 0. So it is 2kq upon pi r square. So it is 2, k is 1 upon 4 pi epsilon naught pi r square and q. So it is q upon 2 pi epsilon naught 2 pi square epsilon naught into r square. Option A will be correct, right? So again, as I told you guys, the process is lengthy. You don't have to do all these things. Just remember the final result, है ना? You will not get this types of question, but I just wanted to show you कि देखो question can be framed in any manner, right? But for NEET, this might not be possible because we have time limitation. We have one question for 1 minute, right? So that is how you can solve it. If you have any doubt, please ask. And this is the final answer over here, q upon 2 pi square epsilon naught into r square. Alright, well done guys, well done. Now next is this question, based on assertion and reason. The surface charge densities of two spherical conductor of different radii are equal. There are two spherical conductor, their surface charge densities are equal, then electric field intensities near their surface are also equal. That is assertion. Reason is surface charge density is equal to charge per unit area. Yes, surface charge density is equal to charge per unit area. Sigma is nothing but Q divided by A. So that is true. Reason is also true because for near to any conductor, the electric field is sigma upon epsilon naught. Sigma are same for these two conductors, so electric field will be same, right? But assertion, correct explanation is not given in reason. The correct explanation of assertion is not given in reason, right? So both are true, but assertion is not the correct explanation of reason over here, right? Well done guys, well done. Now let's try this one everyone, try this one, come on guys, I know you can do it. A charge q is placed at origin, okay. The electric potential due to this charge at a given point in space is V. Let's say at this particular point P, the electric potential due to this is V. Then what is the work done by the external force in bringing the charge from infinity to this point P? Try this one, come on guys. What is the work done in bringing this charge from infinity to this point P? This is the definition of electric potential energy, right? Again, based on definition. Come on everyone, क्या होगा? Work done is equal to, yes beta, well done. Work done is Q delta V. Q delta V, मतलब potential of point P minus potential of infinity. If nothing is given, we consider potential of infinite point as 0. So potential of point P is V. So it is just Q into V minus 0. So it is QV, right? So yes, correct answer is option B. Well done guys, well done. Good job everyone. Now next is this one. There are n capacitors in parallel connected to V volt source. Then energy stored is equal to, we have n capacitor in parallel like this and all are connected to V volt source like this. Then what is the energy stored in this system? Try this one everyone. Energy stored is half into C equivalent into V square. Half into C equivalent into V square, that is energy stored in the system. What is C equivalent? Here I will give you one shortcut everyone. Shortcut, are you ready for your shortcut? When there are n capacitors, equal capacitors in series, then equivalent value of this will be C upon n. ठीक है, C upon n. But when there are n equal capacitors in parallel, then C equivalent becomes n into C. You don't have to do anything. Just apply this shortcut over here. So it is half into n into c into v square, which is equal to b. Note it down beta. This is shortcut for you. है ना? N capacitors in series, equal value, C equivalent will be C upon N. N capacitors in parallel, then C equivalent will be N into C. ठीक है? चलो, well done guys, well done. Try this one, try this one. A capacitor is charged by using a battery. Okay, we are charging a capacitor by using a battery, let's say having potential difference V naught, and after charging we are disconnecting the battery. So it is getting a charge Q naught plus Q naught and minus Q naught on the plates like this, right? Now initial capacitance value is, let's say C naught, right? Then after disconnecting the battery, we are inserting a dielectric plate between the dielectric slab between the plates. ठीक है? After disconnecting the battery, what we are doing? We are inserting a dielectric slab between the plates of the capacitor having dielectric constant, let's say K. ठीक है? अब आपको बताना है which of the following options are true. Come on guys, come on. Yes, 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 Sai Kiran. क्या होगा? What is the answer everyone? Come on. I know you can do it. It will start just like 1 month before the NEET, 1 or 25-20 days prior. ठीक है? Option C, okay. So over here, see initially there was potential difference source, so we have charge like plus Q naught and minus Q naught. Now we are disconnecting it, so charge will be same, charge will not change. है ना? Well done. It will not go anywhere. So charge will be same, but potential difference and energy stored will be different. Well done guys, well done everyone. So over here, since initial capacitance is C, final capacitance will be Kc naught, है ना? After inserting the dielectric slab, capacitance becomes K times, right? So over here capacitance will increase, and we know that Q is equals to Cv. So for initial situation, Q naught is equals to C naught into V naught. Now final situation, again charge is same, but now capacitance is Kc naught, and let's say new potential difference is V, so it is V. So over here you can write to V as Q naught upon K C naught, which is Q naught upon K C naught, and Q naught upon K C naught is V naught, so which is V naught upon K. So over here potential difference is decreasing. There is decrease in potential difference, right? Potential difference is decreasing. There will be no change in the charge. Let's see what is the change in potential energy. So initial potential energy is Q naught square upon 2C naught. Final potential energy will be Q naught square upon 2 times Kc naught, because new capacitors is Kc naught. So over here again potential energy is reducing by a factor of K, right? So again decrease in potential difference, reduction in stored energy, but no change in the charge stored. Well done guys, well done. Option C is correct. Well done everyone. Now next is this one, a parallel, I think it is one of the PYQ. A parallel plate capacitor has a uniform electric field E in the space between the plates if the distance between the plates is D and plate area is A, right? This is the parallel plate capacitor like this. ठीक है? Area is A and separation between the plates is D. Then what is the energy stored in the capacitor where electric field is E between the plates over here? Try this one everyone. Come on guys. क्या होगा? What is the answer? Energy stored per unit volume. Energy stored per unit volume is equal to half epsilon naught E square. So energy stored will be half epsilon naught E square into volume is A into D. A into D, right? So this will be option C. Option C is correct answer. Well done guys, well done. Now try this one. Two spheres A and B over here each of radius A and B respectively are at same potential. Potential of these two spheres is same. The ratio of surface charge density of A to B is, well done. What is the ratio of surface charge density of A to B? Sigma A upon sigma B क्या होगा? What is the answer of sigma A upon sigma B? Try this question everyone. What is the correct answer for this one? है ना, sigma is what beta? Sigma is charge divided by surface area, right? So over here sigma A will be charge on A divided by surface area 4 pi A square. Sigma B will be charge on B divided by 4 pi B square. है ना, surface area of second one is 4 pi B square. It is a sphere. Now, one more critical information is given that both are at the same potential. That means potential of A is equal to potential of B. What is potential on the surface of a spheric sphere having some charge Q? It is KQ upon R, right? So, for sphere A, it will be KQA upon RA, which is A, and for sphere 2 it is KQB upon B, like this. So over here you will get QA upon QB as A upon B. Now divide it beta, 4 pi cancel. So basically this is QA upon QB into B square upon A square, whereas QA upon QB is A upon B. Put it here. So it is A upon B into B square upon A square. Cancel, 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 cancel. So we have B upon A, right? So yes, the ratio is B upon A. Option B is correct. Well done. Beta B is the correct answer. B square upon A square, we are getting it over here, but it is multiplied with QA upon QB. है ना? And QA upon QB is A upon B using this relation, using this information, right? So it will be B upon A. Well done bachcho, well done. Good job everyone. Now try this one. In the electric field of a point charge Q, this point charge Q is placed over here and a certain charge is carried from point A to B, A to C, A to D and A to E. There are 4 paths through which we are carrying a charge in the presence of this point charge plus Q over here through AB path, AC path, AD path and AD path, like this. Then the work done, आपको बताना है, you have to compare work done along all these 4 paths. Is least along path AB, is least along path AD, is 0 along all the paths and is least along path AE, right? Work done is equal to Q delta V बच्चों. Work done is equal to Q delta V. Over here, what is the change in potential beta? What is the change in potential, right? So over here, these are on a sphere. So if potential of this point is KQ upon R, this Q is placed at center. So potential of this point is also KQ upon R, KQ upon R, KQ upon R. So all the points are at the same potential. This is nothing but equipotential surface beta. Equipotential surface. ठीक है? So if all the points are at the same potential, then potential difference between AB is 0, between AC is 0, between AD is 0, between AE is 0. So delta V is 0 for all the paths. So work done will be 0, right? So it will be 0 along the paths AB, AC, AD and AE, right? Well done beta, well done, good job. Now next is this one, the ratio of momenta of an electron and an alpha particle which are accelerated from rest by a potential difference of 100 volt is. So we have momentum is equal to under root 2 m q v. M is mass of charged particle, q is charge and v is the potential difference. Try this one everyone. Okay, we have electron. So mass of electron can be taken as me, mass of alpha particle is m alpha. If charge on electron is E negative, then charge on alpha particle is 2 times charge on proton, so it will be plus 2E, right? So over here P electron is under root 2 m E into E by into V, है ना? M is mass of electron, this E is charge on electron and V is potential difference. P alpha is under root 2 m alpha 2E into V. Cancel, ये divide करो, cancel, 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 cancel. So it is under root ME divided by 2M alpha. Option D is correct. ठीक है, option D is correct. I hope it is clear everyone. ठीक है, right? Now next is this one. 5 capacitors of 10 microfarad each are connected as shown in the figure with 100 volt supply. The equivalent capacitance between points A and B over here is. What is the equivalent capacitance between points A and B over here? Try this one guys, come on. We have 10 more questions to go everyone. So I need you to do calculation a bit faster, right? This is what? If C1, C2, C3, C4 and this is C5. So if C1 upon C2 is equal to C3 upon C4, that means 10 micro divided by 10 micro is equals to 10 micro divided by 10 micro. Yes, it is satisfying this condition, right? That means this is balanced Wheatstone bridge. Balanced Wheatstone bridge. ठीक है बेटा? This is balanced Wheatstone bridge. So over here, this C5 is useless because there will be no charge on this C5 over here. So basically this will be, the reduced circuit will be 10, 10, 10, 10. This is A and this is B. This 10 and 10 are in series, right? So what is the equivalent capacitor of 10 and 10 in series? It is 10 upon 2, 5. These are in series. So 1 upon C equivalent for series is 1 upon C1 plus 1 upon C2. You can use the shortcut. If equal capacitors are series, then the value of equivalent is C upon N. C is value of one capacitor 10 and number of capacitors are 2. So it is 10 upon 2, 5 microfarad. Similarly, this lower branch is also having 10 and 10 in series. So their equivalent will be 10 by 2, that is 5, right? So after reducing this into 2, these two are in parallel between A and B beta. 5, 5. So 5 and 5 are in parallel. So equivalent capacitance in parallel combination is C1 plus C2 plus C3 up to Cn. So it will be 5 plus 5, that is 10 microfarad. Right, so correct answer is option D. Well done Jayanti, well done beta. Option D is correct. ठीक है, चलो, good job everyone. Now next is this one. The expression for the capacity of the capacitor formed by a compound dielectric placed between the plates of the parallel plate capacitor as shown in the figure. Now this is direct formula beta. If you have multiple dielectrics between the plates of the parallel plate capacitor having thickness D1, D2, D3 and so on, and having dielectric constant K1, K2, K3 and so on. So in this case beta, the value of capacitor is given as epsilon naught A divided by D1 upon K1 plus D2 upon K2 plus D3 upon K3 like this. ठीक है? So this is beta direct formula, which is option A. Okay, don't confuse A with B. It is B is D1 plus D2 plus D3 divided by K1 plus K2 plus K3, which is wrong. Alright, so A is the correct answer over here. Now next is assertion reason. Conductor having equal positive charge and volume must also have same potential. Reason is potential depends on charge and geometry of the conductor. Try this one bachcho. What is the correct answer in this case? Conductor having equal positive charge and volume must have same potential. No, a conductor might have equal charge, same potential, but the potential depends on the geometry also. For example, if you look at the sphere, on the surface of the sphere, potential is kq upon r. So it depends on the radius also, right? Volume might be same, but the geometry of the conductors might be different. So it doesn't mean that the potential is same if the charge and volume is same. The geometry also matters, right? So assertion is completely false. Reason is true, right? So correct answer is option D. Assertion is false, but reason is true over here. Okay. Now next is this one, a charged capacitor is disconnected from battery. Now if its plates are separated further, the potential energy will fall. We have a charged capacitor charged up to a certain value, plus Q and minus Q. Now it is disconnected from the battery and its plate are separated further like this. Now we are increasing the separation between the plates of the parallel plate capacitor like this, then the potential energy will fall. What is potential energy beta? Q square upon 2C. So it is Q square upon 2, C is epsilon naught A upon D. So potential energy over here is directly proportional to D. है ना? It is directly proportional to separation. If you are increasing the separation, potential energy will increase, not fall, right? So this is completely wrong. So assertion is false. Energy stored in the capacitor is equal to the work done in charging it. Yes, the work done by the battery in charging the capacitor will stored in the form of potential energy of the capacitor. So over here reason is true, right? So again assertion is false, reason is true. Fine, well done bachcho, well done, good job everyone. Now let's try this. In the figure given below, the current passing through 6 ohm resistor is, total current is 1.2 ampere, we need to find it for 6 ohm, right? So for that I'll give you one formula bachcho, this is 6 and 4 in parallel and total current is 1.2 ampere. So this is R1, this is R2, let's say current in this branch is I1, current in this branch is I2, then beta I1 is given as I into R2 upon R1 plus R2. Current divide itself in the inverse ratio of their resistances in parallel. ठीक है बेटा? By using this you can directly find anything you want, right? So over here we want to find I1, right? So I1 is I, total current is 1.2 ampere, R2 is the opposite resistance divided by R1 plus R2, 6 plus 4, 10. So it will be 0.48 ampere. Option B beta, right? Option B is the correct answer for this one, right? Well done guys, well done. Next is this one, try this one. 2 batteries of EMF 4 and 8 with internal resistance 1 and 2 ohm each are connected in the circuit with a resistance of 9 ohm as shown in the figure. What is the current and potential difference between point P and Q? Right, try this one, chalo. What is the current and potential difference between point P and Q? We have, this is the question number 21st. We have 4 more questions after this and 7 minutes left. Come on guys, I know you can do it. This is the series combination of battery. If the batteries are connected with these dissimilar plates like this, positive, negative, then E equivalent is E1 plus E2, and if internal resistances are R1 and R2, then R equivalent is R1 plus R2 beta, right? If the batteries are connected with similar plates like this, positive, negative, positive, this is E1, this is E2, then E equivalent is E1 minus E2 and R equivalent will be same beta, R1 plus R2. Combination of batteries, combination of cells, series combination. So over here it is connected in this similar pattern, right? Positive, negative, positive, negative, positive, negative. So what is the equivalent? 8 minus 4, E1 minus E2, 8 minus 4 as 4 volt, right? So if you draw equivalent circuit, 4 volt is the equivalent value of EMF and total R equivalent will be R1 plus R2, 1 plus 2, that is 3 ohm, and it is connected to 9 ohm external resistance, and this is point P, this is point Q over here, right? So in this case beta, total resistance provided in the circuit is 9 plus 3, that is 12 ohms, right? So I is equals to V upon R, which is 4 upon 12, that is 1 by 3 ampere, right? So 1 by 3 ampere over here is the current in the circuit, and potential difference across P and Q is equal to potential difference across 9 ohm resistor. So it will be I into R, 1 by 3 into 9, that is 3 volt, right? So correct answer is option A. Alright, well done guys, option A is correct. Now next is this one, the current voltage graph for a given metallic wires at two different temperatures is T1 and T2 as shown in the figure. The temperature T1 and T2 are related as, what is the relation between T1 and T2 over here? So it is, dekho, I versus V graph is given, so I upon V is 1 upon R. So 1 upon R is equal to slope of IV graph over here. Now this angle of inclination is deciding factor for slope. So theta for T1 is more than theta for T2. So slope of T1 graph is more than slope of T2 graph. If angle of inclination is more, then slope will be more beta. Okay? It is more for T1 than T2. But slope is 1 upon R. है ना? If slope is more, 1 upon R will be more, that means R will be less. Right, so if slope for T1 is more, then resistance for 1 will be less than resistance for 2. If slope is more, resistance will be less. Right, so resistance for 1 is less than 2, that means temperature at 1 is less than temperature 2. Right, because resistance of a conductor increases with increase in temperature. Right, so if resistance is more, that means temperature of that particular resistance is more. So T1 is less than T2, which is option B over here. Right, well done bacho, well done. T1 is less than T2 over here. Now let's try next question. The resistance of a wire is 10 ohm, its length is increased by 10%. By stretching, the new resistance will be. So for that I'll give you one more classic shortcut. Right, if L length and resistance is R, if NL length, then resistance will become N square times R. If you are changing the length of the wire by N times, then new resistance will be N square times. Okay? You can derive it in your homework. Right, so over here, if initial length is L, then new length will be L plus 10% of L, which is 1.1 L. So over here, if length is L, resistance is R, if length is NL, resistance will be N square R. Now what is N? N is 1.1 beta. So N square will be 1.21, 1.1 whole square. So new resistance will be 1.21 times the old resistance. Old resistance is 10, so it will be 12.1, which is approximately 12, option A. Okay? Fine. Now next is this one. If power dissipated in 9 ohm resistor is 36 watt, the potential difference across 2 ohm is, okay, power dissipated in 9 ohm resistor is 36 watt, then what is the potential difference across 2 ohm resistor? So what is power? It is V square upon R, which is 36. So V square is R into 36, which is 9 into 36 over here. So V will be 3 into 6, that is 18 volt beta. So potential difference across this 9 and 6 combination is 18 volt. So over here current through this 9 ohm resistor will be V upon R, which is 18 upon 9, 2 ampere, and current through this 6 ohm resistor will be 18 upon 6, that is 3 ampere. So basically 2 is going there, 3 is going there, that means total current should be 5 ampere. That means this battery is providing total current of 5 ampere. So potential drop across this 2 ohm will be 5 into 2, that is 10 volt over here. Right. So correct answer is option B. 10 volt is the correct answer. Alright. Okay. Next is, oh, this is the last one. Oh my god. Chalo. So we did all the questions over here. Well done everyone. So these are your 25 questions for today's session. I hope you learned a lot in each and every question. So please make sure you are marking your mistakes over here, and if you are learning something, highlight it. Okay, because these are the shortcuts that will help you in increasing your speed in NEET exam. Right. So guys, the notes of the session you will find here in this Telegram channel. Our Telegram channel link is given in the description box, and daily updates also you will find there. So please join this channel ASAP, and again Like this session, share this session with your friend and subscribe to Infinity Learn NEET by Sri Chaitanya so that you get maximum benefit from this channel, right? So that is it for today's session. Don't go anywhere. We have one more session for you. Thank you so much guys. Take care everyone. Bye bye. All the best.